This section 4.3, congruent triangles. These are the objectives. Use properties of congruent triangles. Second one is prove triangles are congruent by using the definition of congruence. This is the vocabulary. You can pause, but I'm moving on. Let me read this to you. Geometric figures are congruent if they are the same shape and size. Let me give you these two pictures here. Actually, 4 pictures. Out of these, there's only 2 that are actually congruent. This is the one that is congruent. This is these 2 are not. And as you can see, by what we read at the beginning of this slide, it makes sense that the 2 yellow are not congruent. Let's formally define congruent polygons. And here it is. 2 polygons are congruent polygons if and only if their corresponding angles and sides are congruent. Very important definition. Moving on to the next slide. Let's look at this illustration. It says properties of congruent polygons. So in this diagram, they're telling you that these 2 triangles are congruent. So what can we conclude from this? We can conclude that corresponding angles are congruent. In the same manner, corresponding sides are congruent. Whenever you have congruent polygons, corresponding angles are congruent, corresponding sides are congruent. That's why if you have these 2 polygons that are congruent, in this case these 2 rectangles, corresponding angles are congruent and corresponding sides are congruent. Let me move on to the next slide. So it's given that a triangle XZY, which is right here, and this other triangle NPQ are congruent, we need to identify the congruent parts. So here we go. Which angle is congruent to angle Z? So this is angle Z. In this triangle, angle Z is congruent to angle P. For number 2, PQ, here's PQ. PQ is congruent to which side in this other triangle? YZ. And moving on, angle Q congruent to angle Y. Angle X is congruent to angle N. And Q, which is right here, is congruent to XY. And the last one, PN, is congruent to ZX. If you're having trouble seeing this, this is not too complicated. This is what you want to do. If you look back to the given information, and I want to see which angle is congruent to angle X, notice that that's the first letter in this triangle. So this angle is going to be congruent to the first letter in this triangle. Angle X is going to have to be congruent to angle N, and notice that's what we came up with. Let's look at a side. Say that I want to see which side is congruent to PQ. I look at PQ, the last 2 letters here. So I look at this, and it's going to have to be XY. And that's what we have, or YZ. And you can come up with all the answers using this idea. Moving on to the next slide. So again, you're given that these 2 triangles are congruent. And then you need to find the value for each of the problems here, 7 through 10. So they want you to find X. How do we find X? Notice that this is the expression that has the variable X. So then this is what we need to do. I recognize that angle E is equal to angle R. They're congruent by definition. Congruence, equality means congruence. So then all I'm going to do is I'm going to substitute. I know that E is 4x plus 6 and R is 90 degrees. So then all I need to do is solve for X here. Take away 6, I get 84, divide both sides by 4, and this is my answer, 21. To find letter Y is in here. And again, I need to use this fact. that angle G is congruent to angle T, and by definition of congruence is also equal. So then I set up this equation. 5y minus 2 equals 28. Then from here, I'm just basically going to solve for y. Add 2, and then divide both sides by 5, and that's how I end up with 6. How do I find angle F? Here, I know that this is 28. So then I know that these two angles must be complementary. Why? Because I know that this is 90 degrees. From here, I substitute, and that's how I end up with 62. And then the last one, how do I find ST, which is this side here? I notice that FG and FT are equal. They're congruent, but by definition, they're equal. I notice that I can use that over here, ST and FG. So they must be equal. From here, I substitute, solve for Z. What I did is I added 8 to both sides, divide both sides by 2, and I get 6 for Z, and then I go back and plug in Z in here, and that's how I end up with 10. Here we go. Here's number 3. This is a proof. It says given that angle Y, WX, and YWC are right angles. And you're also given that WY bisects this big angle, XYZ. And then also, there's a lot of given information here, but let's go through it. W is the midpoint of XZ. And at the end, XY is congruent to YZ. And what you're trying to show is that you want to show that these two triangles, the triangle on the left hand side is congruent to the triangle in the right hand side. So in order for me to do that, I need to show that corresponding angles are congruent and corresponding sides are congruent. So it's going to be time consuming, but not too complicated. So here we go. So we're given this. They are right angles. So from here, I can say the following, that these two angles are congruent because they're right angles, and this is by right angle congruence theorem. We saw this a while back. Next. So I have shown that these two angles are congruent. So now I know that this bisects this big angle, so I know that this is congruent to this. And that was given, and here's number 4. That's what I highlighted a second ago. So these two angles, XYW, is congruent to ZYW, and this is by definition of bisector. Number 5, W is the midpoint of XZ. So then this is what I can do. Let me change the color here. Since W is the midpoint, again, this was given, I know that this is congruent to that. Why? This is by definition a midpoint. Number 7, I know that YW is congruent to itself. So this is congruent to itself. And this is by the reflexive property of congruence. And then I know that angle X is congruent to angle Z. Why is that? This angle is congruent to this angle, and this is by the third angle theorem. Then number 9, almost there. XY is congruent to YZ, and this was given. So I can use the tick marks. And now, at this point, I have shown that corresponding angles are congruent, corresponding sides are congruent. So then I can say this, and the reason is definition of congruent triangles. Next slide. Here's number 4. So I have to prove that these two triangles are congruent. This is the given information. You have segments bisecting each other. And AB congruent to D and angle A congruent to angle D. So here we go. So I'm given that angle A is congruent to angle D. So that's my reason. Number 2, BCA is congruent to DCE, and I'm talking about these two angles. Why are they congruent? because they are vertical angles. Or vertical angles theorem, the reason. 3 says angle ABC is congruent to angle DAC. So I'm looking at, change the color here, this angle congruent to this angle. And why? This is by the third angle theorem. Number 4, AB congruent to D. This was given. Notice that it's already marked. This is also given. They're saying that these segments bisect each other. So then I can say this. Since they bisect each other, then BC is congruent to EC. In the same manner, AC is congruent to DC. And this is by definition of segment bisector. At this point, I have shown that corresponding angles are congruent, corresponding sides are congruent. So these two triangles are congruent by definition of congruent triangles. Moving on to number 5. Number 5 will be the last one. Again, show or prove that these two triangles are congruent. Given information, PR and Q2 bisect each other. PQS and RTS are congruent, and QP is congruent to RT. So I want to show that these two triangles, QPS and TRS, are congruent. So what I'm going to do is I'm going to ignore this part of the picture. So just ignore this segment here and this segment here, so I won't throw you off, since I'm going to be working with these two triangles. So here we go. Number 1, QP is congruent to RT. Let me mark it. And this was given. Number 2, PQS is congruent to RTS. PQS, so this angle, RTS, these two are congruent, and this was also given. Now, PR and QT bisect each other, and this was also given. So then I can say the following. Change the color. Excuse me. So this segment is congruent to this segment, and this segment is congruent to this segment. And this is by definition a segment bisector. Then I can say that QSP is congruent to TSR, and I'm talking about this angle is congruent to this angle. The reason is because they're because the vertical angle theorem, vertical angles theorem, or you can also say the vertical angles are congruent. And then at this point, all I'm missing is this angle P and angle R. So these two angles are congruent by third angle theorem. And then at this point, I have shown the corresponding parts of these triangles, angles and sides, are congruent. So then I can say that these two triangles are congruent by definition of congruent triangles. This is the end of the video.